Hi, and welcome back to AWS Julie. We are going to wrap up this new playlist where we're talking about the machine learning fundamentals that you need to understand to help you prepare for the AWS Certified Machine Learning Engineer Associate exam. And before we begin, I want to emphasize that security is one of the biggest and earliest considerations that you'll make when designing an architecture. This includes defining how the people, the tools, the pipelines, applications, the model that you build will access the necessary AWS services and your data. This could involve determining not only who or what can launch or terminate your resources, but also managing how and when access is given, along with any operational permissions and almost anything else that would involve calls to the services. So for the exam and for fundamentals of AWS, ensure you understand the AWS shared responsibility model and the AWS global infrastructure, and especially the different resilience of different AWS services. One area that is often overlooked when studying for any AWS certification exam is AWS accounts. AWS accounts may seem too basic to take time to understand, but I consider it part of the required need-to-know fundamentals for AWS. You must understand what accounts are and how they work to ensure you can secure access to your AWS resources. But let's jump back to fundamentals and ask a question. What level of service is AWS Identity and Access Management, or IAM? Is it zonal, regional, or global? IAM is a global AWS service that secures any data in the AWS IAM database across all AWS regions. And let's jump back. So across all AWS regions. Let's go back. Okay. So for the exam, review the best practices regarding root user security, applying the principle of least privilege, and multi-factor authentication. AWS accounts begin with a single root account user with full permissions except for one security policy. Do you know what permissions have to be granted to the root user? It is AWS KMS keys. They are not accessible by the root user unless that access is explicitly granted. IAMs start with no permissions, but permissions can be granted. And this is important to understand along with the principle of least privilege and reducing your blast radius. By default, IAM users and roles don't have permissions to create or modify SageMaker resources. They also can't perform tasks using the AWS Management Console, the AWS CLI, or AWS API. You must create IAM policies that grant users and roles permissions to perform specific API operations on the specified resources that they need access to, and then attach those policies to the IAM user or groups that require those permissions. SageMaker supports specific actions, resources, and condition keys for IAM identity-based policies to allow or deny actions and resources, as well as the conditions under which actions are allowed or denied. Amazon SageMaker performs operations on your behalf using other AWS services. So remember that you must grant SageMaker permissions with an IAM execution role to use these services and the resources that they act upon. And to ensure least privilege permissions with Amazon SageMaker, you can use Amazon SageMaker Role Manager to build and manage persona-based IAM roles for common machine learning needs directly through the Amazon SageMaker console. Amazon SageMaker Role Manager provides 3 pre-configured role personas and predefined permissions for 12 common machine learning activities. So for your exam, dive deeper into IAM policies. There are 2 types of policies in AWS. Identity-based policies that are attached to an IAM user, group, or role. And these policies let you specify what that identity can do, so its permissions. For example, by attaching the Amazon SageMaker Full Access Managed policy to an IAM role for data scientists, they are granted full access to the SageMaker service for model development work. And you can also make sure you understand how to configure access control for teams or groups within Amazon SageMaker using attribute-based access control or ABAC. And resource-based policies are attached to a resource. You can attach resource-based policies to SageMaker S3 buckets, Amazon SQS queues, VPC endpoints, and AWS Key Management Service encryption keys to specify who has access to the resource and what actions that they can perform. Let's continue on with securing our AWS resources. It is best practice to provision your machine learning components in an isolated Amazon VPC with no internet access. SageMaker components, including notebooks, training jobs, and hosting instances, can be provisioned in an isolated Amazon VPC with no internet access. SageMaker also gives you the ability to control the network access and internet connectivity of SageMaker notebooks. Direct internet access can be disabled to add an additional layer of security, and this same concept can be applied to your SageMaker notebooks by choosing to launch the notebook instance in an Amazon VPC to restrict which traffic can go through the public internet. When launched in an Amazon VPC, the notebook instance can be configured either with or without direct internet access. Traffic to public endpoints such as S3 or the SageMaker APIs can be configured to traverse over your VPC endpoints to ensure that that traffic stays within the AWS network. You can also use VPC endpoints and endpoint policies to further limit your access. And we talked about this earlier throughout this playlist. You can have your AWS resources be directly connected with public endpoints such as S3, CloudWatch, and SageMaker API, or the SageMaker runtime through an interface endpoint in your Amazon VPC instead of connecting over that internet. For example, access to an S3 bucket can be restricted only to a specific SageMaker domain or set of users, and each domain can be restricted to have access only to a specific S3 bucket, which outlines how to secure SageMaker connectivity using a private VPC. You can also grant access from only within the Amazon VPC with an IAM policy that can be created to prevent users outside the VPC from accessing SageMaker or SageMaker notebooks over the internet. This ensures access to only connections made from within the VPC. As an example, this policy can help restrict connections made only through specific VPC endpoints or a specific set of source IP addresses. This policy can be added to every user group or role used to access SageMaker or the Jupyter notebooks. Dive deeper into IAM user groups and roles and what goes into deciding between which to use and how they might be combined. Also, dive deeper into best practices for controlling your access to the AWS APIs. And lastly, understand the methods, services, and tools available that help you create traceability for access to your AWS resources. Just as you need to be aware of the performance behaviors of your application components, you need to have insight into who and what has access to your account resources and your data. We've mentioned the principle of least privilege several times, and this is key for security at each layer. Do you know how to design and implement the principle of least privilege throughout the whole machine learning pipeline to ensure only those who need access have just the access that they need? That's a great project to work through while you're preparing for this exam. Let's also talk about data security and ask a scenario question of how to automate a solution to keep your data secure and prevent manual logins to an instance that caused a data breach for your application hosted on EC2 instances in an auto-scaling group. One solution is to install the CloudWatch agent on the instances, set up a CloudWatch log subscription, create a Lambda function to add a for deletion tag to any instance that produces an SSH login event, create a second Lambda function using a CloudWatch event bridge rule to terminate all instances that have the custom for deletion tag. Now, I added this question even though it relates more to architecting than machine learning because I want to point this out and make this distinction. By default, when you create a SageMaker Notebook instance, users that log into that notebook instance have root access. And the reasoning is that data science is an iterative process and you might need to test and use different software tools and packages. So many notebook instance users need to have root access to be able to install these tools and packages. And because users with root access have administrator privileges, users can access and edit all files on a notebook instance with root access enabled. So to secure shared SageMaker Notebook instances, you can use IAM policies when granting individuals access to notebook instances that are attached to an Amazon VPC that contains sensitive information. For example, you grant access to a notebook instance with an IAM policy for specific users. So the distinction is for both EC2 instances, you have to grant all access. But for SageMaker Notebook instances, you need to secure that access. And also for both, you need to ensure that you're using the principle of least privilege. Amazon SageMaker Studio uses file system and container permissions for access control and isolation of users and notebooks. And this ties back into adding security based on our access patterns. Certain services, such as Amazon S3, give you the ability to manage security for your entire buckets, but also to add controls based on specific paths or objects. You can also add intrusion detection and prevention with AWS Gateway Load Balancer that can be used to deploy, scale, and manage the availability of third-party virtual appliances such as firewalls, intrusion detection and prevention systems, and deep packet inspection systems. Additionally, the AWS Network Firewall can be used to filter outbound traffic, for example, to specific GitHub repositories. AWS Network Firewall supports inbound and outbound web filtering for unencrypted web traffic. For encrypted web traffic, server name indication is used for blocking access to specific sites. In addition, AWS Network Firewall can filter fully qualified domain names. If access is needed to an AWS service that does not support interface VPC endpoints or to a resource outside of AWS, you can configure a NAT gateway with security groups to allow outbound connections. Let's continue on with task statement 4.3 to secure our AWS resources, and let's talk about data retention, classification, and data recovery. There are best practices for securing sensitive data in AWS data stores. Ensure you understand general data security patterns and a clear mapping of those patterns to cloud security controls. AWS provides the AWS Cloud Adoption Framework with a specific security perspective to help. It is important to understand what data protection looks like for your architecture and your requirements. Here are questions to consider. How do you design data protection when using a VPN over the internet, or a private connection through AWS Direct Connect, or connections between VPCs, or for the transfer of your data between services such as Amazon S3 and your VPC? And how do you protect that data in transit when reaching end users over the public internet? Ensure you understand how to protect data at rest with AWS KMS that can be used to encrypt your machine learning data, Studio notebooks, and SageMaker Notebook instances. SageMaker uses KMS keys by default for more control on encryption and key management. And S3 Bucket can host notebook snapshots and metadata. Amazon Elastic File Systems or Amazon EFS volumes contain Studio on notebook and data files. And Amazon Elastic Block Store, Amazon EBS volumes, are attached to the instance that the notebook runs on. KMS can be used for encrypting all of these storage solutions. Encryption keys can be specific to encrypt the volumes of Amazon EC2-based SageMaker resources, such as your processing jobs, notebook training jobs, and model endpoints. Federal Information Processing Standard endpoints can be used if FIPS 140-2 validated cryptographic models Modules are required to access AWS through a command line interface or API. And to protect data in transit, AWS uses HTTPS communication for its APIs. Requests to the SageMaker API and console are made over a secure sockets layer connection. In addition to passing all API calls through a TLS encrypted channel, AWS APIs also require that requests are signed using the signature version 4 signing process. This process uses client access keys to sign every API request, adding authentication information as well as preventing tampering of the request while it's in flight. Additionally, communication between the instances in a distributed training job can be further protected and add another level of security to protect your training containers and data by configuring a private VPC. SageMaker can be instructed to encrypt inter-node communication automatically for the training jobs, and the data passed between the nodes is then passed over an encrypted tunnel without the algorithm having to take on the responsibility for encrypting and decrypting that data. Let's jump back to the principle of least privilege and talk about recommended best practice of using version control to track code and other model artifacts. If model artifacts are modified or deleted, either accidentally or deliberately, version control helps to roll back to a previous stable release. If model artifacts are stored in S3, versioning should be enabled and also be paired with multi-factor authentication delete to ensure that only users authenticated with MFA can permanently delete an object or change the versioning state of the bucket. You can also associate Git repos with a new or existing SageMaker Notebook instance and add version control. SageMaker supports GitHub and other Git-based repositories. Additionally, the SageMaker model registry can also be used to register, deploy, and manage models as discussed in an earlier SageMaker pipeline lesson. And to tie in logging and monitoring from our last lessons and also compliance, Amazon SageMaker is part of multiple AWS compliance programs, including FedRAMP, HIPAA, and others, and third-party audit reports can be downloaded using AWS artifacts. Understanding your data security options will require understanding of how these services operate, their security options, and how the services will interact. For the exam, ensure you dive deeper into the security pillar of the AWS well-architected framework. AWS provides tools and features to help you secure your AWS environments, and we've mentioned those before, such as CloudTrail, CloudWatch, GuardDuty, and so on. And that wraps up Task 4.3 and this playlist to help you prepare for the AWS Certified Machine Learning Engineer Associate Exam. We've talked about a lot of machine learning fundamentals. So while you're preparing for this exam, or you're building projects to help you prepare for this exam, prioritize security at every layer, study with security in mind, and evaluate not only how protection can be added to original designs, but also how you can reinforce security in existing deployments.